All right, so let's take a look at another example for our right triangle trigonometry, since I forgot to assign homework last night. My bad. All right, so here we have a wire is attached to the top of a telephone pole that is 150 feet tall. The angle of elevation formed between the ground and the wire is 43 degrees. So we want to find how far away the wire is in the ground from the base of the pole, and then we want to find the length of the wire. All right, so this is a two-part. So again, we're going to draw a picture, help us out, set up our triangle. All right, so here's my telephone pole. Here's my wire attached to it. And there's the ground. Now, if you got it flipped, that's okay, as long as you have a right triangle. Okay, if you have it drawn the other way where the telephone pole is on the right, it doesn't matter, as long as you label everything correctly. So the information they give us is that the telephone pole is 150 feet tall, right? So that's going to be the vertical here. That's going to be 150 feet. The angle of elevation formed between the ground and the wire is 43 degrees. So here I can put 43 degrees. So first we want to find how far away the wire is in the ground from the base of the telephone pole. Okay, I'm going to call this G for ground. I'm going to call this W for wire. Now be careful. In the past, I've seen some confusion happen with this scenario. So like if you weren't given the part B to tell you to look for the actual length of the wire, a lot of people see how far away is the wire and they automatically think this part. All right. So if you ever see base of the pole or base of the light post or base of the mountain or base of the whatever we're talking about, okay, a base is the bottom, right? So usually when you see the base, we're talking about this bottom horizontal part. All right, so don't get confused there. All right, so for A, we're looking for G, right? We're looking for how far away is this from here. So here's my angle, 43 degrees. So with reference to the 43 degrees, right, we want to label our sides. Obviously, W is our hypotenuse. 150 feet, what we know, is across from the 43 degrees. So that is going to be our opposite, which leaves the ground part to be our adjacent. So if I'm looking for the ground and I know the opposite, we have the adjacent and opposite. So that tells us that we're going to use our tangent function. So we're going to take the tangent of 43 degrees. That equals opposite over adjacent. So we have 150 over G. All right, so here's an instance where our variable is in the denominator, right? So we can go through those steps, or you can use that trick I told you, and we can swap. So I'm going to move G off to the left side, and now I'm going to have 150 divided by the tangent of 43. So we can type that in. 150 divided by the tangent of 43 degrees, right? I'm in degree mode, yep. And we get 160, we'll say 0.9. All right, we're talking about distance. Our units here were given in feet, so our units over here will be in feet. All right, any questions about part A? All right, then for part B, they want to find the actual length. Is that somebody saying something?
Mr. Mary, there's not like one specific way you have to do it, right? Like if we were to use quotation, I think that's how you say it.
I mean, you could use cotangent and do g over 150, right? Because yeah, you're right. You could use the cotangent of 43 equals g over 150 because we would swap those. But the issue there is there's no cotangent here. Okay, be careful. These, we haven't talked about these yet. The sine -1, cosine -1, tangent -1. Okay, they're not. This doesn't mean cosecant. That doesn't mean secant. That doesn't mean cotangent. If you're using a computer, you can type in cotangent, no problem. I'm looking for my graphing calculator. Graphing calculator, similar situation. Okay, we don't have those buttons. We don't have them on there. But, I mean, we know that cotangent is 1 over tangent. All right, so I can set it up like this. And then when I solve here, right, I multiply both sides by 150. And I end up with the same situation in order to calculate it. So you could use cotangent, but then in the process of solving, you still end up with that.
All right. Would you
Is that kind
prefer
of...
us to use? Yeah, it does. It does. But I'm like
Okay.
saying, would you prefer us to use your way?
I mean, I'm trying to keep it as simple as I can for you guys, and these three, sine, cosine, and tangent, are as simple as you're going to get for trigonometry. So yeah. So just to kind of keep you from making mistakes, right? You don't want to make the silly mistakes like if you forget to do the 1 over tangent, things like that. But if you feel more comfortable setting it up like that, so you don't have the variable in the denominator, then by all means, go ahead.
All right. Thank you.
You're welcome. Good question. Good question. All right. So for part B, we are now looking for the hypotenuse. Right. So again, like I said yesterday, I could go ahead and I can use this 160.9. So if I want to set up the cosine using my adjacent and hypotenuse, I could do that. But just in case, maybe I made a mistake, maybe it's not 160.9, I'm going to go back to the original information they gave us. So I'm looking for the hypotenuse. I was originally given the opposite, so that would tell me I'm using the sine function. Okay, so again, you could use the cosecant since it's hypotenuse over opposite, right? You would have the cosecant w over 150, but then you'd go through the same steps over here, right? And here, you know, it's not much more, but it does, you do have to do like an extra step from here to here, right? So, you know, it's not a big difference. It's not going to take up too much of your time, right? But it is more work, right? And part of math is doing things as quick as possible, right? To find the shortest way to get from point A to point B. You don't want to overcomplicate things. Right, so here to solve for our hypotenuse, to solve for W, I'm going to have 150 over the sine of 43. All right, so when we do that, I'll use this one. 150 divided by the sine of 43. I wasn't typing anything in. Cool. All right, we get 219.9. Yeah, we'll say 219.9. All right, so we have that there. Now, just a general hint, a general word of warning. If we were finding the hypotenuse is always the longest side, right? So you should always end up with a larger number than your opposite or your adjacent, okay? If I calculated this and somehow I ended up with, I don't know, like 143 or 120 or something like that, I know I went wrong somewhere because I wouldn't have a triangle if this side was shorter than those two sides. All right, so that's just something you can look out for when you're solving these. All right, any other questions? All right, so these problems, they don't really get much more complicated than this right for now. So your main issue is making sure you set up the triangle and putting the correct information where it belongs. All right, so if you had the 150 in the wrong spot, then that's going to mess you up. All right, so just make sure your diagram is as accurate as possible. All right, so we don't have much time, but I do want to get started on the next lesson so we can just jump into it next week. All right, so we figured we use the unit circle to evaluate trig functions of our special angles, right? Using the unit circle, we have $20 different spots, right, that we have, right? So you have, the 0 degrees, 30, 45, 60, going all the way around, right? But like I said earlier, life's not that simple. It's not so cut and clear. We're going to be dealing with angles that aren't those special angles, right? So we need to be able to figure out the trig functions of any angle. So we're going to be talking about angles in standard position. All right, so now we have a few different parts. We're going to have our angle, obviously. We're talking about trig. Normally that involves angles. But now, somewhere on our line, we're going to use our coordinates. Okay, so we have an x and y coordinate. With that, we can calculate the length of this terminal side, and we're going to call that r, okay, for radius, essentially. So all right, so here we have theta, which is any angle in standard position with a point xy on the terminal side. Okay, so we can calculate, we're probably going to have to calculate r, and to do that, we're going to use Pythagorean theorem. All right, so we can calculate r by taking the square root of x squared plus y squared. All right, so from this, we can find our 6 trig functions. Okay, the sign is going to be y, which we get from the unit circle, divided by your radius, because now our radius isn't just 1. Right? In the unit circle, we had the special condition that the radius was 1 unit. But now that may not be the case, so we have to set up y over r. Our cosine is going to be x over r. Our tangent is still the same as the unit circle, and that's going to be y over x, right? That's sine over cosine. Then for our other functions, cosecant is going to be r over y. Secant is going to be r over x. And then cotangent, x over y. So then we have some rules that depend on our quadrants. All right, so I'm going to make this pretty big because we have some information to write in our quadrants. All right, so let's remember what our quadrants are. Up here we have quadrant 1, right, which is between 0 and 90 degrees. Here we have quadrant 2, between 90 degrees and 180 degrees. Down here we're going to have quadrant 3, between 180 and 270. And here we have quadrant 4, between 270 and 360. And obviously we have the the radian rule as well, but I don't have enough room to write all that. So in our first quadrant, no matter what we take, the sine, the cosine, or the tangent, the values will always be positive. So if you take the sine, cosine, tangent, cosecant, secant, cotangent of anything between 0 and 90 degrees, your answer will always be positive. In our second quadrant, all right, because now over here, my x value is negative, anything that involves an x will also be negative. So sine is still going to be positive, but cosine and tangent will have negative values. So if I take the cosine of 150 degrees, I don't know what it is exactly right now, but I know that the answer is going to be negative. Okay, if I take the tangent of 150 degrees, that's also going to be a negative. But if I take the sine of 150 degrees, that's going to be positive. In our third quadrant, this one's special because both the x and y are negative down here. So that means my sine is going to be negative, my cosine is going to be negative. But for tangent, I'm going to have a negative y over a negative x, which makes tangent positive in the third quadrant. So any angles between 180 or 270 degrees, your tangent is going to be positive. And then if you've kind of figured out the pattern, right, if you notice what's happening, in our fourth quadrant, our sine and tangent are going to be negative, and our cosine is going to be positive. Right. And then obviously we have some special things that happen at 90 degrees, at 180 degrees, at 270 degrees, and at our 0 or 360 degrees. Because here, no matter what point we're looking at, it could be really close to the origin, it could be, a mile away. You have zeros for either your x or your y coordinates, which messes some things up here. Okay, so again, that's why we can't always take the tangent and the cotangent of certain numbers, because it involves a 0 in the denominator. All right, I think that's all we're going to cover for today. We don't have enough time to look at some examples, so we'll leave it there. All right, and then next week we'll pick up from here and we'll talk about actually calculating. All right, guys, have a great weekend. I will see everybody on Monday.